All right, let's continue. So just like I said, sine of x, that's when my angle was x, right? Sine of x is equal to cosine of 90 minus x. I can say sine of 90 degrees minus theta, where theta in this case is my angle, is the same as saying cosine of theta, right? So if I have cosine, somebody give me a value for theta.
21.
50.
21.
21. All right. What's the value for cosine of 21?
0.933580425. So we can put
0.93.
yeah.
All right. Now tell me, hold on. So, okay, let me not put the 3 because just 0.93, right? If I said now, sine of 90 minus 21, which is sine of 69, can you tell me what's the value for that? Sine of 69.
0.93.
0.93. So yes, this is true. That's the relationship between sine and cosine. Cosine, by definition, it literally means complement of sine. Complement meaning complementary angle. Complementary angle means that the sum of the angles of the two angles add to 90 degrees. Okay? Oh my, I did not mean to do that. But yeah, everybody good with that?
Probably.
Probably. What kind of probably? What do you mean by probably? Yes or
Yes.
okay.
I mean, like he technically can't speak for the whole class, so yeah, probably is right.
Oh, okay, that makes sense. So just a little proof to show that what we were saying is true. Say I have a right angle triangle. Sorry, it's fine. Say I have a right angle triangle. So we know trigonometry. Gosh, I didn't tell you this before, but let's just do it now. Can anybody tell me what trigonometry means? Like, do you know what I mean?
Triangle
sides.
geometry.
Okay, triangle geometry. Any other answers? Anybody? What do you think?
I was gonna say the study of three sides, or like the science behind three sides, or something like that.
Or the study of
The
triangles.
mathematics behind three angles.
Or yeah.
Oh, the mathematics behind
Sokotoa.
three-sided shapes.
Yeah,
Three-sided
basically like Sokoto and
parallelograms.
shit like that.
Wait, what? No.
Three-sided parallelograms.
Forget I said that.
What?
Oh gosh, this is cakes. Anyway, so
Cut.
study of triangles, triangles, measurement of triangles, you know. But how exactly did they come about that? Well, try. When you hear try, what do you mean? I mean, what does that sound like? What do you think about when you hear try?
Tree?
Three.
Like, you know, tree in your backyard, they go and
Right.
climb.
Oh god, no. Three. So the number 3, right? Gone. Does anybody know what this means? It's a
So,
Greek word.
Hold on, miss. Let me Google that.
Shape. It means shape for sure.
Quick Google.
Does it mean angle?
It
in
means
Latin.
angle. Wait, you sure it's Latin?
No, I'm not sure. I literally just guessed because like Latin is popular in math.
Nah, it's Greek. But that's a lesson for a whole nother day. It's because of classical physics and how the Greeks, you know, they were the first to discover all of this, like Archimedes and all them. But anyway, that's history lesson is one other day. Trigonometry. What does that sound like?
Metric,
Math.
like metric,
Metric.
like measurements or something like that.
Metric. Yeah.
Oh, lovely, lovely.
Measurements. Yeah, so let me just put famous measurements. That's why trigonometry means the measurement of three angles or triangles, you know? Just the study of triangles and all of that, right? So let's go back to what we were doing. That's just a little history thing there. Anyways. Right. So say I have a right angle triangle, my angle theta. If this angle is theta, what would this angle be?
Which one, miss?
This angle right here.
The opposite.
No, what would be the value of this angle? If this is theta, this is a right angle triangle. So this is 90, this is theta. So what would be this value?
Not sure, miss. Theta 2 or something like that.
No,
No. Isn't it
Um,
a squared plus b squared equals c squared, right? So
What?
that's nothing to do with this.
not
David,
to remember
Damari,
what
chill.
sides of
Okay, let me ask you a question. The sum of all angles in a triangle, three angles in a triangle, adds to what?
180 degrees.
180 degrees,
Mhm.
right? So if I know that this angle is theta, I know that this is 90 degrees. So hold on. Let me explain this a little. If I know that this is 90 degrees, right? I know that the other two angles must add to 90. Why? Because 90 and 90 is
Oh.
180. You get that, right?
Uh-huh.
Oh,
Yes,
yeah,
miss.
yes, miss.
So if these two angles must add to 90, ninety degrees is equal to
Is it equal to theta?
plus this here.
Yeah.
That's assuming that theta, these two are the same, right? So
Yeah.
45, 45. But if this wasn't 45, if this was like 15 degrees, what would be this answer?
180 minus 90 plus 15.
Okay, and what's that value?
75.
Yeah.
We know that this is 90, and these two must add to 90, right? So what I wanted you to, pick up on. And if you don't get it, please let me know, right? Like if you need me to explain it to them. What I wanted you to pick up on was that if I have a right angle triangle, I know that the sum of all three angles is supposed to give me 180. I know that this is already 90. And if I have an angle theta, and I know that these two angles must always sum to 90, it means that this angle right here is 90 degrees minus whatever theta is. Just like here, if I said that theta is 15, to find the value of this angle, I know that these two must add to 90. So what number plus 15 is going to give me 90? It's 75. That's why this angle right here is theta was 90 degrees minus theta. You get that?
Oh, yeah.
Yeah.
Makes sense.
Because they need to add up to 90.
Yeah.
The other two angles.
Right. So let me call these sides. So just erasing it, right? This is me showing you that sine theta and cosine of 90 minus theta, they're the same, right? So say this is A, this is B, and this is C. If I ask you for cosine, right? Give me cosine now. Sine of theta. What would you tell me? We know that's opposite on hypotenuse. What's the opposite side? A, B, or C?
No, B.
Opposite B.
Wait, what?
You.
Say that again.
Good.
Opposite side. to
Miss,
the-
go. Oh.
Opposite the 90 degrees, the hypotenuse.
No, this.
B of
Opposite theta.
Oh, that is the adjacent.
Yeah, so C is the hypotenuse.
How is the opposite
B
of
is the
theta adjacent?
opposite, and yeah, A is the adjacent.
What?
Grid.
Question mark.
You understand why sine of theta is B and
What?
C?
Yes, miss, I do. They don't. So yeah.
Good. Who doesn't understand that sine theta is B?
Wait, Miss, give me 5 seconds to process it real quick.
Okay. 1, 2, 3, 4, 5. You good? Okay, let me do that again.
No,
Definitely not.
I figured. Okay, let me do that again. I have my right angle triangle. You understand why this is right angle? Why this is called a right angle triangle?
Yes, miss.
Yes.
Okay,
yes, Miss. Yeah.
I said theta. If I name my sides A, B, C, we know trig functions, right? SOHCAHTOA.
Yeah.
Sine is opposite on hypotenuse, cosine is adjacent on hypotenuse, tan
Oh
is
yeah,
opposite.
SOHCAHTOA.
Yes, yes. So if I ask you
Yeah,
what's
so
sine, if I ask you what's sine theta, what would you tell me?
what's sine
Opposite.
theta?
Opposite over hypotenuse.
Opposite over hypotenuse.
Oh, well, so
Come on, guys. Fourth
SOHCAHTOA.
form.
So
Fourth form,
opposite
man.
over.
Yes, Johnny.
Come on, man. Yo, chill, Damari, chill.
So sine is opposite on hypotenuse.
Miss
But in
Damari is
terms
so aggressive. You know, chill.
okay, let me do this again. Sine theta opposite on hypotenuse. But in terms of sides A, B, and C, which side, A, B, or C, is opposite to theta?
B, side B.
All.
B. No.
P.
Who said all?
B is opposite.
Does Johnny.
The person who said all, that was a joke, right?
No,
Yeah, it was.
guy,
It was cool.
wasn't.
Okay.
It was Johnny though.
And if I
I
ask
don't
you
know.
for
It was a soft voice. Stop laughing.
if I ask you for the hypotenuse, which is the longest line in the triangle, then which one is it? A, B, or C?
C.
Let's see.
Side C.
C. Good job. Now I told you
See,
that this angle here.
it's always opposite the right angle.
Oh, well, yeah, the hypotenuse is always opposite to the right. So just in case anybody didn't know that, that's a little trick for you to remember remember which side is the hypotenuse. Right. So we said that this angle here is 90 minus theta. Why? Because all three of these angles must add to 180 because it's a triangle. Now, if I ask you to find the cosine of this angle here, 90 minus theta. So we know that cosine is adjacent on hypotenuse. Which side is adjacent to this angle? A, B, or C?
Hey,
Adjacent.
To which one?
Miss, what you said?
I asked which side is it? It's B. So I don't know who told me B, but good job. Yes, it's B. And which side is the hypotenuse?
C.
C. Notice sine theta is B on C, and cos of 90 minus theta is also B on C. And that just proves to us that sine theta is in fact equal to cosine 90 minus theta. So that was just another way of me showing you that it is true. And that's how cosine and sine are related, right? So can I clear this?
Yes,
Yes,
miss. Yes,
miss.
miss.
Yes, miss.
Right. So now look at the graphs. If you need me to actually draw it on the black screen, please let me know. But you see this yellow line? That's my sine graph, my sine curve, the one we drew before, right? And then the blue is my cosine curve. Notice that they look similar. So the maximum is still 1, the minimum is still -1. However, they're just 90 degrees, also known as pi radians apart. So we know the sine when we are drawing it, it starts from 0, goes up to 90, then comes down and goes up, right? But cosine starts at 1, comes down to 90, 180, whatever. Both of these graphs look similar, but they're only 90 degrees apart from each other. Why? Just like I showed you just now, the relationship, they're like cosine is the complement of sine. That's why, right? That's why these graphs look like that. You understand?
So miss, basically, you're saying that at the points which they cross is 90 degrees?
Okay. Look at this. Look at so my physics people, you would know that this up here is the crest, right? And this is called the peak of the wave. Look at this peak. Look at this peak. My physics people, you know that this is called lambda. Lambda is my wavelength. Non-physics people, don't worry about this, right? My physics people, you would know that this is called lambda. Right?
Yes, miss.
Okay. This wavelength, this is 0, this is 90. That is why we say that they're 90 degrees or pi radians apart from each other. Like the crest, yeah, they're 90 degrees from each other. You
Okay,
good with
that
that
makes
now?
sense.
All right, yeah. So for my non-physics people, did you understand that? Just the distance between this point here and this point here, it's 90 degrees. That's why we say it's 90 degrees apart from each other, right? Okay. Same thing with these points here, right? They're also 90 degrees apart from each other. This is at -360. This is at negative 270. Difference is going to give me 90, right? That's why we say it's pi radians or 90 degrees apart from each other. Tan. Tan looks kind of wonky. Okay. So, like I said, you have to learn these graphs, right? So just like my sine and my cosine, I choose any value of x and I put it into my function. I realize that the points make this pattern. Unlike my cosine and sine graphs, where the maximum value was 1 and the minimum was -1, tan does not have a maximum and a minimum value. Here in this diagram, they only go up to 1.5, but it actually goes up to positive infinity and goes down to negative infinity, right? There is no limit. Okay, do you understand that? Yes, no? Let me explain it quickly. Okay, that's one yes. The others, do you understand that?
Yes, miss.
All right.
Yes, miss.
Like I said, you just have to learn these, right? Okay. So what's my other one? Okay, that's the end of this topic. Oh, so I only have 3 minutes again. So it doesn't really make. No. I could just start the new thing one time. Oh, I could do
Miss,
yeah.
Miss, are you gonna help me and Damari to with our past paper, the 2015?
Yeah.
Okay, thank you, Miss.
Okay,
Good
actually,
stuff,
I'll
good
just,
stuff.
I would stop there with the graphs. Next class, all we have to do is solving, and that's it for tricks. But I needed you to know about this before I could show you how to solve them. So yeah, on Tuesday, we solving trig equation. Anybody who isn't in the WhatsApp group chat, please let me know so I can send you the link. Hold on. Let me. Right. So we're doing product rule. Right. So this is the expression that they gave. 2x squared plus 3 sine 5x. They want me to integrate now, differentiate this expression. So just said, we will be using the product rule. What is the product rule? Do you know what the product rule is?
Where you multiply what's in the brackets by what's outside of the brackets? Question mark.
No. Anybody knows what the
Oh wait, okay, you multiply what's outside by what's in, and then you differentiate what's outside by what's in, and then you differentiate what's inside of the bracket and like add it to it or something like that.
Or do you multiply both of them, what's inside and outside, and then you differentiate them?
Okay, so let me let me tell you the product rule. You would see this commonly used for the product rule. U would dv on dx plus v du on dx. Does that look familiar?
Yes.
Oh yeah, du and dx. Yes,
I remember that.
Yeah, I remember that.
Okay, so I'm taking u to be 2x squared plus 3. If u is equal to 2x squared plus 3, then du on dx, so the rate of change of u with respect to x is equal to what? If I differentiate this expression, what would I get?
4x.
4x. 4x.
Yeah, for it.
All right. Now we're dealing with v. V would be this, right? Sine 5x. So if v is sine of 5x, what's dv and dx?
Cos 5.
Cos of what? Cos of what?
Cos by 5.
Close.
Miss, how do you differentiate a sign?
Okay, so the differential of sine is cosine, positive cosine, right? So I'll put cos of 5x, right? However, you also have to multiply by the differential of this. What's the differential of 5x?
5.
5.
Oh, 5.
Therefore, dv and dx is 5.
5.
5x.
That's crazy.
Huh? Can I what?
No, I was just saying something. I was saying something I remember.
Okay. So now that we know du and dx is 4x, dv and dx is 5 cos of 5x. Oh, I erased the wrong thing. Anyways. So my product rule, according to my product rule, it's u dv and dx. So u is this. Let me erase this top part. Somebody just remind me, what's the product rule?
U dv over dx plus v du over dx.
Exactly. So u in this case is 2x squared plus 3. dv and dx is 5 cos 5x. And then we said this is adding to v du dx. V in this case was sine 5x, and du on dx is 4x. So I'll just write it here. So you can expand these brackets actually. So you can have like 10x squared plus 15, well, 10x squared. So they said in the simplest forms, right? You don't have to expand it. Just saying, you could leave it just like this. Or if you want to, I guess you could expand cos if x plus 15
Wait, Miss. Oh, never mind.
plus 4 sine x. Well, 4x sine 5x. So you could leave it like this, or you could expand this matter, right? Same thing. You good with this one? This is the answer. In yellow.
Yes, that's plus 4x sine 5x.
Yeah.
Oh.
Can I erase this now?
Yeah, miss.
Wait, Miss. Wait. Okay, yes, Miss.
For the person, who was it? K Headley. That thing that you put in the chat, that's not the product rule. It's similar to the it looks like you're trying to type what you put there looks similar to the quotient rule, but that's not the quotient rule either. The quotient rule, it's minus, not plus. Right? So yeah. I'm teaching that subject. I mean subject now, topic just now. But yeah. So what's the second part of this question? To find the coordinates of all stationary points of the curve y is equal to x cubed minus 5x. Yeah. How do we find stationary points? Anybody knows?
Stationary points.
Differentiate first and equate to 0 and find x.
Okay. In case anybody did not know that, at the stationary points, the gradient function, which is dy on dx, is equal to 0. So in order to find what? I'm teaching this topic next, right? So for the people who don't know what I'm saying, it's cool. This is the next topic. Right. So at the stationary points, dy on dx, which is also known as the gradient function, is equal to 0. Why? Say I have a curve, stationary points. If I drew a tangent to this point, it's a horizontal line. The gradient of a horizontal line is 0. Hence, the gradient function is equal to 0 at the stationary points. Just in case you didn't know that, right? So what I need to do is to find dy on dx. I am given this equation. I'm given this equation. Y is equal to x cubed minus 5x squared plus 3x plus 1. So if I want to find dy on dx, what would be my answer?
X squared minus 10x.
What's the differential of x cubed?
3x squared.
3x squared. The differential of minus 5x squared.
Minus 10x
Okay.
plus 3.
And at the stationary points, we know that this, so this is going to be equal to 0. 3x squared minus 10x plus 3 is equal to 0. Now that I have an equation, I can solve for my values of x. If I factor this and all that, this will give me 3x x minus 3 minus 1. Yeah. Hold on, let me just. Yep. Okay. Therefore, my values of x would be x is equal to a third and x is equal to 3. But that's just the x values of my coordinates. I need to find y. You might be wondering, but why do I need to do that? Well, a coordinate is in the form xy. We know the x values, but now we need to find out what's the y values. So, anybody has any idea how we would find the y values of the coordinates?
We plug the x values into the equation.
Into the equation. Okay, let me just erase the whole thing.
Oop, less than a minute.
Oh, well, let me end it, rejoin, so I can finish this.